Welcome students, myself Sundeep from IT department, AKGEC Engineering College, Ghaziabad. Today I am going to learn about binomial heap, binomial tree and binomial heap. What is binomial tree and what is binomial heap, what is the uses of that, we are going to learn. About binomial tree, the binomial tree represented by B K with the subscript K is an ordered tree. Binomial tree is ordered tree defined recursively, means if one part is there, then that part will be represented recursively again and again. As shown in the below figure A, this is below figure A, the binomial tree B0 consists of only a single node. This is B0. B0 is having only a single node and if we are saying about BK, then BK consists of two parts, as we have said earlier recursively. BK consists of two parts. First part is BK minus 1 and another part is also BK minus 1, which are connected together. Then the binomial tree BK consists of two binomial trees BK minus 1 and that are linked together. The root of one is the leftmost child of the root of the other one. Means BK minus 1, first one BK minus 1 is connected as a left child to another BK minus 1 part. Then that is a binomial tree which I am talking about. Figure B, in the below figure, there are the various binomial trees are given B0 to B4. This is B0 which is having only one node, B1 which is having two nodes, B2 having 4 nodes, for example, B3 is having 8 nodes and B4 is having 16 nodes. And how these nodes are coming? B0 is the starting or initial binomial tree which is started with one node, that is called a B0 or initial binomial tree. If we are going to create B1, means binomial tree with level 1, means the previous one is at level 0 only, which is having only one level, means level 0. Level 0 is having only one node and in which we are talking about the level up to level 1. Up to level 1 means if we are talking about BK is equal to BK minus 1 plus BK minus 1. For example, BK minus 1, if we are talking about B1 is equal to B0 plus B0, means two parts are there. One is another B0, another one is B0. First one B0 is this, second one B0 is this, and first one is connected as a left child to another one. That totally becomes with the B1. Then we coming to the B2. B2 is also having, again if we are talking about B2 plus B1 plus B1, means we are having B1 like this. In B2 we are having two B1s, one is there, one is there, and first one B1 is there, second B1 is there. The first B1 is the left child of another one, which is coming from this definition. Next we coming to the B3. B3 is again having the B3 is having B2 plus B2, means two B2s are there, means last B2 is having 4 nodes. So this one is a one B2 and this one is another B2. So B3 is a combination of B2, two B2s, one B2 and second B2, and first B2 is the left child of root node of another B2. Similarly, we are coming to the B4. B4 is another combination of two B3s. So one B3 is having 1, 2, 3, 4, 5, 6, 7, 8 nodes So this is one B3 and this is another B3, and first one B3 is connected with the root node of another B3 with as a left child. And if we are talking about the levels or depth, this is level 0, depth 0, 1, 2, 3 and 4. That's why we are saying it B4, and here we can say that 0, 1, 2, 3. So this is saying as B3, 0, 1, 2. So as per the levels of the tree, we are saying it B2, 0, 1, we are saying is as B1, and this is only at level 0. So we are saying it as a B0, binomial tree with their depth. Next, we are coming about to the properties of binomial tree. For the binomial tree, BK is the representation of binomial tree. There are 2 raised to power k nodes. This is the 2 raised to power k is the maximum number of nodes which is having a tree which is BK. The height of the tree is k. There is exactly ki nodes with a depth I, and a root has degree k which is greater that of any node. Moreover, the children of the nodes are numbered from left to right by k minus 1, k minus 2, k minus 3, so on to up to 0. And child I is the root of the next subtree bi. Again, coming to the on depth, the binomial tree is the collection of binomial heap. Binomial trees we have discussed. Then coming to the binomial heap, the binomial heap is the collection of various binomial trees. The binomial tree, again we are exploring the binomial tree again. Binomial tree is ordered tree denoted by BK, where k is an order, B0 is the 0 order tree. We have shown in last part and total nodes in a binomial tree we are having 2 raised to power k. For example, we have already seen BK. If we are talking about BK, which consists 2 BK minus 1. So first BK minus 1, second BK minus 1. If we are talking about B0, means with the depth 0, there is number of nodes are only 1, means 2 raised to power k. If we are having the formula 2 raised to power k maximum number of nodes, then k value is 0 here in B0. So 2 raised to power 0 means only 1 node is there. We are talking about, if we are talking about B1, then 2 raised to power 1, there are maximum 2 raised to power, there are maximum 2 nodes. B2, so 2 raised to power 2, which is having total 4 nodes. In binomial tree, root of one becomes the left child of another. Similarly, if we are talking about the level 3, B3, if we are saying it is a B3, it is a combination of 2 B2s. This is first B2, this is another B2, and first B2 is the total first B2 is the left child of another B2's root or root of the next B2. So BK is the BK minus 1 plus BK minus 1. B0 again we are saying about 2 raised to power 0 is equal to 1, means at level 0 only, or showing with the node. So we are having only one node which is showing here. B1, 2 raised to power 1 is equal to 2. So we are having 2 nodes. First node is this, and again second node is this, which is connected with the previous node as a left child, like this. B2 is equal to 2 raised to power 2 with the help of 2 raised to power k is having a total 4 nodes, and which is the combination of 2 B3, no, B1. B2 is the combination of 2 B1 plus B1, and B1 we are having like this, means first B1 is this and second B1 is this, and the first B1 is connected as a left child with another B1 like this. Binomial tree B4, if we are talking about the B4, which is the combination of another two B3s. At level 4, we are having the connection with this part along with this part. Means at level 4 or B4, we are having two B3s. First one B3, second B3. If we are talking about the level 0, 1, 0, 2, 0, 1, 0, 3, means 0, 1, 2, 3. 0, 1, 2, 3. Means it has become the level when two threes are combined together, that will become the level 4. And total nodes are here for total 16, because there are two B3s are combined together and one B3 is having total 8 nodes, and which is 8 nodes, and total nodes are equal to 16. Properties of binomial tree, there are 2 raised to power k nodes. The height of the tree is maximum k. There are exactly k factorial divided by k minus 1 factorial or I factorial. If we are talking at depth I, I is taken as the depth number. If we are talking about at depth I, how many nodes will be there? So at depth I, we are having exactly k factorial divided by k minus 1 factorial multiplied with I factorial. This formula will give us the total number of nodes present at level I. The root has degree k. Similarly, if we are having degree 4, the root is having degree k. So because there are three levels are there, B3 and B3, but root of the combined binomial tree is having level 4. Again, we are talking about this formula. If we are searching in this tree, how many nodes are at level 0? So we are putting values in this formula. 4 factorial divided by 4 factorial and 0 factorial, that is 1 divided by 1 is equal to 1. So we can say that, we can see at level 0 we are having only one node. Again, we can see at level 1 means there is value of I is 1, means 4 factorial divided by 4 minus 1 factorial means 3 factorial multiplied with 1 factorial. 4 into 3 factorial by 3 factorial, so total nodes are 4. Means if we are talking about at level 1, there are 4 nodes, 1, 2, 3 and 4. If we are talking about level 2, so 4 factorial divided by 2 factorial divided by 2 factorial into 2 factorial, and by which we are having total 6 nodes. So 6 nodes we are having at level 2. At level 3, if we are talking about at level 3, how many exactly nodes are there? So 4 factorial divided by 1 factorial, 1 is coming by the 4 minus 3 factorial, and I, value of I is 3, so 3 factorial, by which we are having only 4 nodes. At level 4, which is the highest level, we can say 4 factorial divided by 4 minus 4 factorial means 0 factorial and multiplied with I, and I is this one 4. So 4 divided by 4, that is 1. So at level 4 we are having only one node. Coming to the binomial heap. So what is binomial heap? As we have said earlier, binomial heap is the collection of various binomial trees. The binomial heap is the collection of binomial trees, and properties of binomial heap. Binomial heap contains the minimum heap property. So minimum heap property means minimum value of any vertex is coming to the root. For any non-negative integer k, there is at most one binomial tree whose root has degree k. So there is a figure given in which there are figure B0, B2 and B3. There are 3 binomial trees are connected together, which are making it as binomial heap. So this is having only one node, means level 0. It is the binomial tree of the level 0 means B0. This is having total 4 nodes means 1 and 2 means 2 B1s are there means it is B2 means this part is a level 2 binomial tree. And coming to the B3, B3 is the combination of 2 B2s means in this binomial heap we are having 3 binomial trees, one is B0, one is B2, one is B3. Graphical representation of binomial heap, if we are talking about this one, then this is connected to the this one, this is connected to this one, this one, this one. Then what is the graphical representation of this one? This whole binomial heap. The graphical representation of binomial heap, we are having 1, 2, 3, 4 and 5 fields. The first field represents the parent node or the value of parent node, or second one is the key. Key means the value of that particular node, degree degree of that node, the value of his child, value of that child of that node, and value of that sibling node. Means if we start from this B0 node present at B0 which is having value 10, means the key value is 10, parent of 10 is none, degree is B0 by which we have finding the Bk, k is the degree is 0. Then child, this node is not having any child means no any child. After that, coming to the sibling, there is one node represents the sibling which is connected at the similar level, which is the part of B2 which is having value 1, means 1 is the sibling of this node which is having value 10. Then this node which is the sibling of 10 is connected to another node. So connected to another node by which 6. So this is connected to 1, 2 means this is connected to 1, 2, 25 means this one is having 12, 25, 18 means one node is having 2 childs, 12 is having 1 child. So we are talking about this means it is connected to this one which is having 2 childs 12 and 25. 12 is having another child which is 18 means this represents the second part. This represents the second part, this one B2. B2 is represented by this part. This is represented by B0 means B0 is represented by this part. B2 is represented by this part, and the part leftover part is B3 is represented by this part. Similarly, we can explore this thing again. Means if we are having 6 at value key value in which we are having 3 nodes as a child 8, 14, 29. 8, 14, 29 we are having 3 childs 8, 14, 29. Whose parents is this node means parent is 6, 6, 6. After that degree of that particular 8 values node degree is 2, and 14 is having degree 1. 14 is having degree 1. 29 is having degree individually 0. 29 is having degree 0, and 29 is not having any child, also not having any sibling. 14 is having a child node which is 38. 14 is having a child which is having 38. 18 is having 2 childs 11 and 17. So 8 is having 2 nodes as a child 11 and 17. 11 is again having 1 child which is 27. 11 is having again 27. Similarly, we can see in B2 in which parent node is 1. There are two childs 12 and 25. Parent node is 1 which is having 12 and 25 whose parents are 1 only and 12 is having another child which is 18 whose parent is 12 and 18 is not having any child, not having any sibling. So, this is the graphical representation of binomial heap in which different types of binomial trees are combined together. Operations, what operations we can perform on binomial heap? There are 7 operations. First one is make heap. So, we have to make heap initially with no element, means we have to initialize a heap in which there is initially no element. Insert h comma x means insert node x in binomial heap h which is created recently. So, we have created binomial heap h in which we have inserted node x. So, insert h comma x works as it is inserting node x in recently created binomial heap. We can find minimum h, minimum value in particular binomial heap by this operation minimum h. It returns a pointer to the node in the heap whose key is minimum. Extract minimum h represents means the value of the minimum node minimum key from that binomial heap, means extract or delete that particular node from the minimum heap whose key is minimum. Next one is union h1 h2. H1 h2 is, if we are talking about union, it creates and returns a new heap by merging h1 and h2 both together that contains all the nodes of heap h1 and h2. It means h1 and h2 will be destroyed. H1 and h2 initial recently which are having their existence differently, means individually, that existence will be destroyed and that will be the combined in the union h1 h2. Second, next one is decrease key, means if we are in heap h, we are having some node x and we are assigning the value k to that x, means assigning a new value k at node x, means we are decreasing key value as k from node x at node x. Delete the node means we are in heap h and we are having x node, means in h heap we are going to delete x node. So, we use the delete hx. Next operations are there. Create binomial heap. The head of h is equal to null. So, initially when we try to create the heap, the initial value of heap node or head node means or root node is nil. The finding the minimum key, for finding the minimum key, we are having these types of pseudocode. The binomial heap minimum h, by which we are assigning value nil to y, x, we are assigning head value of h to x, we are assigning infinity to minimum, while x not equal to null, which is the head value, while it is not equal to null, if key of x less than minimum, which we have assigned infinity, then minimum is equal to key of x, and then we assign value of x to y, which we have initially taken as nil. Then x is the sibling of x. If we have compared x with infinity, then we have assigned x value to y, then we coming to the next sibling value of x. then return y. Return y value is going to the previous y value. And that this will give us the minimum value of key present in binomial heap. There is a question for the same. If same question is there, 10, 1, 6. So y is initially nil. X is the head of x. Head of x is 10. So x is having the value 10. Minimum is equal to infinity. We are assigning infinity as a to minimum variable. While x not equal to null means 10, x value of x is 10, which is not equal to nil. It is there. If key of x less than minimum, what is the value of minimum? Value of minimum is infinity, means the value of x, which is we have seen recently, is 10. 10 is less than minimum, 10 is less than infinity. Then we assign minimum is equal to key of x, means we have to assign key of x which is less than infinity to minimum variable. So then minimum variable becomes 10. Then we assign x to y, means recently we have seen x value is 10. Then we assign x to x or 10 value to y. Then what is going in x? X is again pointing to the sibling of x, means sibling of x is again 1, means we have compared 10 and we have put it the value of 10 in this procedure, and after that we are comparing the value 1 which is present as a sibling of 10 in that particular binomial heap. Then we return the value y. While x not equal to null means when we assign the sibling value to x, means sibling value of x is x. X value of x has become the value 1. Then we are comparing x not equal to nil, means now we are having value of x is 1. 1 is not equal to nil, is true. Then key of x less than minimum, means again we are checking the same procedure which has already checking here. Again we are checking x value of x less than infinity, which is always true. Then minimum value we are assigning minimum value to 1, means if this is the minimum from the infinity, then we assign 1. Then 1 or x value assigned again to the y, and x has become the value, means yes, sibling of last x. The sibling of last x is 6. Then we going to the next value. So we are going to the next value again for the 6. Again we are checking for the 6. If while x not equal to nil, 6 not equal to nil, is true. Key of x less than minimum, key of x, abhi last we are having the minimum value 1 in the last step, and we are checking with the current value of x with the last value of minimum, which has become the false, and which has become the false means x is the sibling of x. So this is the next procedure where we have not put it the value of x value to the y, we have put it the value sibling to the x, means x is becoming null and return y as a answer. Means we have compared 10 in this procedure, we got value y. After that we have compared 10 with 1, so we got the value y as a 1. After that we had compared 6 with 1, where the condition has become the false, and the last value which we had stored is the final, becoming the final answer, which shows the minimum heap value in binomial heap. Union of two binomial heaps. There are four cases are there. First case represents case 1 occurs when degree of x not equal to the degree of nu of x. Means if we are having, in the last procedure, if we are having at binomial heap a, b, c, d, there are 4 values are there, and we are at x or at b, which is, we are saying this is x, and next of x is c. Means if we are having the degree of x not equal to the degree of next of x, means it is degree of b is not equal to the degree of c, then we forward the value of x, means we forward x to next value, means then become c become the next and d becomes the next of x. Case 2 occurs when the degree of x equal to the degree of next of x and equal to the sibling of next of x. If we are having all the degrees are same, then we started from the x, first node a, which is at present in first case x, this is the next of x, and c is the sibling of x. Similarly, when procedure 1 or recurrence 1 is completed, then x value becoming to the b, means and second time x is b, next of x is c, and sibling of x is d, when we are having the same degree. Case 3 and 4, case 3 and 4 occurs when the degree of x is equal to the degree of node of x but not degree of the sibling of x. So we are considering 3 values at a time, x, next of x and sibling of x. We are now comparing all the 3 values. Degree of x is equal to degree of next of x is not equal to the degree of sibling of next of x. If we are having key of x less than equal to key of next of x, then key of x and next of x like this, then we change this particular node to the left child of first node. Means if key of x is less than or equal to key of node of x, means second value is if there is second value is less than or equal to the value of x by which we are comparing, then it becomes the child node or left child node of first one node. Means we are making union or decreasing the heap, means this whole part becoming the left part of first node. Second part is what second condition may be key of x greater than equal to key of next of x, then means this is value is greater than or equal to this one. Our purpose is to making minimum heap. Minimum heap means at root node we have to have minimum value. So a and b, from a and b, a is having large value, a is having large value, then b is having less value. From this condition, then the less value node has to become root node and less value part or whole node or whole part will become the left child of less values of b values. B part means b node becomes the parent of this node. Thank you.